Greetings, my name is John Gabriel, and this is the new Calculus channel. Today I'm going to continue my talk about the concept of number and how it came to be, and mention some interesting things that are a consequence of what I discussed in this particular video that you see here, which is what is a number in layman's language. Let's take a look at some interesting concepts that one can realize when studying how we got the concept of number. So let's begin. Now, in the last video I showed you how you could actually do arithmetic operations, but they're not really arithmetic operations as you find in algebra. Of course, the algebra actually comes from these arithmetic operations. You can do everything here geometrically. So I showed you how you can do a multiplication by simply moving these points on the circle. And I also mentioned to you that you can derive all these concepts here, without the numbers of course, from nothing in a perfect way, without any axioms or postulates. And I've written many articles on that, and I've produced some videos also, and you can read those. There are my 2 world-famous articles on how we got number, and also the 5-part series on there are no axioms or postulates in mathematics, which in fact overthrows all the ridiculous, misguided notions of mainstream academics the past 400 or 500 years, perhaps longer. So now, when we look at this diagram here, we see that it doesn't matter how we move these. The product or the multiplication of this dark blue line and the light blue line will always yield the red line, right? Now, in this case here, nothing has been defined as a number. These here are just magnitudes. And in fact, I've written 1 next to this, but this 1 doesn't have to be that length. 1 could easily just as well have been that length, right? So this here could be the unit. Okay, it doesn't necessarily mean that this length here is in fact the actual unit. It's only the unit if we choose it to be. So the unit is something that we in fact choose. Oops, and something looks wrong here. Yes, this is not right because I shifted the unit here to 2, but let that be as it may. I'm not going to worry about this right now. It's actually 2 times 5 is equal to 5 times 2, but if you have a 1 here, then that's true. Anyway, it just all depends on what length you choose for the unit. So let's just push this back to 1, okay? Like so. And notice that one might be tempted to think, well, you can measure any other line with this unit. But can you really? Just think about that for a while. It would seem that you can even measure pi, whatever it is, 3.1459, with a unit. This is really what we're being told by this diagram, that it's possible to measure it. However, if you think about it very carefully, that's not what this is saying. It's not possible to arrive at a measure for pi using the unit, even though you can actually say pi multiplied by this 1 unit, the magnitude pi, not the number pi, the magnitude multiplied by this unit gives us the magnitude pi, right? But a measure is very different to a magnitude. As I said earlier, if we move the unit to 2, then, you know, this length here that we call pi would actually be twice as long, wouldn't it? Right? It would be 6.2 whatever. So the measure of a magnitude is a number. The measure describes, the measure of a magnitude is really what composes a number, what makes a number. So if we can't measure a particular magnitude with a given magnitude, like 1 in this case we can measure this length here exactly, because we have 1 measures this 3 times, doesn't it? Okay, so it's very easy to see here that we can actually measure any magnitude, provided that it's either a certain amount of equal parts of the unit, or multiples, or both. But there are many, many magnitudes, like pi, and square root 2, and all the other things, right? Square root 2 somewhere over here, 1.4, whatever, which cannot be measured by 1 or any equal division of 1, right? There is no measure for it. And hence, when we say pi, we shouldn't really call it a number. It's a magnitude. It's not a number, okay? Similarly with square root 2. We're looking at a magnitude, not a number, because not even the gods can measure pi and square root 2 and any magnitude that is incommensurable. That's why the ancient Greeks called pi and square root 2 and all those magnitudes that could not be measured incommensurable. That's what incommensurable means. And since the ancient Greeks, no one has been able to measure those magnitudes. Why? Because they can't be measured. It's as simple as that. See, it doesn't really matter if you could produce through advanced mathematics, such as you find in calculus and other areas. You can produce trillions of digits of square root 2 or pi, whatever it is. Those digits do not describe pi or square root 2. That they're not even accurate to within 0.0000 with trillions of 0% behind it, 1, okay? They're not even that accurate. Even if you had to sit down and write those digits out forever for the rest of your life, if you could live forever, you still wouldn't even get close to 0% of accuracy. 0.001 with infinitely many zeros in between. You still wouldn't get close to that accuracy, which means whatever you have is not pi or square root 2 or square root 5 or any other incommensurable, the measure of any other incommensurable magnitude. So that is an interesting piece of information when we look at this diagram, because we can do any of the arithmetic operations on magnitudes. And of course, Euclid covered this in Book 5 of the Elements. In Book 5 of the Elements, all he dealt with there were ratios. And the ancient Greeks knew these facts. And now I, the great John Gabriel, reveal these facts to you. I'm bringing you into the new age of enlightenment, okay? The new calculus, the fallacies which are going to be removed from mainstream mathematics, and everyone is going to understand math and do math and be good at mathematics, because there is no such thing as an individual who is no good at math. Only morons who've been sitting on top of the mathematics trash heap the last 200-300 years, okay? People like that idiot Gilbert Strang from MIT, or Jack Hazinger, an ex-Harvard alumnus, or any of those fucking morons I've had the displeasure of dealing with. Okay, those are the idiots that have actually made mathematics into mythmatics and brought it to a point where it can't be learned anymore. They didn't have the ability or the intellectual prowess to realize that there is no such thing as a real number. And in fact, it's not even necessary in calculus or in mathematics. And everything works perfectly fine in the new calculus without infinity, without limits, without infinitesimals. So I hope you've enjoyed this little presentation. If you want to ask a question, feel free to ask a question. If you have an attitude, I'll probably ban you. So let me know if you have any more questions, and I'll try to answer. In fact, I'm sure I'll answer, because I'm not the great John Gabriel for nothing, ain't I? Very well. I hope you've enjoyed this little presentation and that you'll join me again for the next exciting presentation. Till next time, goodbye.